We're going to go through the basics of scientific notation, mainly because in a lot of our equations, we're going to need to be able to plug these into a calculator, either very, very large or very, very small numbers. So, what is scientific notation used for? Well, like I said, it is used for very large or very small numbers. The general structure that you see for scientific notation is some sort of number between 1 and 10 to the power of something for 10. So, for example, let's do a very large number. So, how about like 1.1 times 10 to the 8th? This is a very large number because it has a positive exponent. So large. So positive power or exponent. If we were to do a very small number, then we would need a negative exponent. So how about like 9.95 times 10 to the negative 20? How about that? That's a very, very small number. So this is small because it has a negative power or exponent. But notice in both examples, the number that's before the times 10 is some number between 1 and 10. You will only ever see one digit in front of the decimal. Now, depending on what type of calculator you use, the age of the calculator, the brand of the calculator, the type of calculator, whether scientific or graphic or anything like that, they all have a certain coding within them that determines when a number is too big for standard form or too small for standard form. For that reason, let's go through how to convert between the two. If you are working on an example problem with a friend and using two different calculators, you might get the exact same number, but it looks different in the calculator. So, for some examples, let's see, how about somewhere around here is where some calculators will switch between standard and scientific. So, one of you and your friend, one of you might have this number appear, so 5,760,000, as standard form. The other one might see it in scientific notation. So, what would this look like? Well, we start on the far left. And after our first non zero digit, which would be our 5, we would put a decimal. So 5.76 times 10. Now we need to figure out what the exponent is. Our implied initial decimal is here at the end. And it says here, if you have to move that decimal to the left, then it is a positive exponent. So you will jump from the end 1, 2, 3, 4, 5, 6 places. And so it'll be times 10 to the 6th. These two numbers are exactly the same number, but may appear in these two different forms in your two different calculators. Now let's do a very small number. 0.000411. How about that? So one of you might see this number in the calculator. And how would the other person see it? Well, again, we start from the left, and we find our first non-zero, which is 4. So it will be 4.11 times 10. Well, now we have to jump to the right. 1, 2, 3, 4 places. And so it will be a negative 4. These two numbers are exactly the same, though in different forms. So let's just hit a couple of these. Okay. How about let's do number 2 and number 4. So what I would do is pause and try these yourself first, and then unpause to see the answer. Our first non-zero is 2, so it will be 2.3 times 10. Here is our implied decimal, 1, 2, 3, 4. 2.3 times 10 to the 4th. In this one, our first non-zero is the 3, and there's nothing after it, so it would just be 3 times 10. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the negative 9. All right, let's go the opposite direction. So scientific to standard. Let's see. Say a calculator gives us 9. How about just 9? Let's just do that. So 9 times 10 to the negative 5. Let's start with negatives. In this problem, the 9 has an implied decimal right after it. Since it is a negative exponent, we need to make this number smaller. So we need to go to the left 1, 2, 3, 4, 5 places. Anywhere where there are blanks, you will put zeros. And so this number in standard form would be 0.00009. All right, let's do about 8.8 times 10 to the 3rd. So this one actually has a decimal, and since it is a positive exponent, it needs to become bigger. And so we will jump the decimal 3 places to the right. 1, 2, 3. This time, I'll tell you what, let me move that 8 a little bit over. There we go. This time we have 2 empty spots on the right side. And so this number in expanded form would be 8800, 8,800. Now, let's do a couple of examples. Let's see. How about, let's just do 2 and 4 again. So once again, I would suggest pausing this, trying it on your own, and then going back and checking your answers. All right, here we go. This is a positive exponent, which means it should get bigger. So here's our decimal. We're going to go 1, 2, 3, 4, 5. So we have 2 extra spots afterward. So we will do 3, 4, 3, 2, 0, 0. For number 4, I'm going to erase my 0 here now, or my circling. This is a negative exponent, so we're going to move our decimal to the left to make it smaller. 4 places. 1, 2, 3, 4. Any empty spots? We put zeros. 0.0007678. And that is it for scientific notation.